Hi, this is the third segment of the capstone lecture series. Today we're going to be talking about a topic that's very important to me, and this is race, genetics, and ancestry DNA tests, which are the place in which most people, the average person, is going to interact with the science of DNA within their life. Two things at the start here. First, this final lecture is going to talk about the history as well as history and well as current events that have to do with race. This will include a mention of torture, suicide, violence against children, and racialized violence, and there's also a reference to sexual assault. Before any slide of those that mentions these, as well as the preceding slide, will have a little circle in the upper corner so that you can skim through and check and sort of skip ahead if you would like to avoid any of that. Secondly, I would like to acknowledge that I am recording this, and the land that I live on, as well as the land that the schools that I teach are on, was stolen from the Monacan people, who still live on this land today. They, at the time that the first colonists arrived in what was called the New World, the Monacan people already had a complex agriculture system. They were cultivating many foods: beans, sunflowers, grapes, nuts, squash. They had a complex society. I still do. And despite having lived on this land for over 10,000 years, were only federally recognized on the 1st of January 2018. So let's get into it. There are a couple problems with ancestry DNA testing. This is the thing that, if you're not familiar, this is the thing that you've seen the commercials on TV, I'm sure. They say things like, oh, well, I discovered that I was part Italian and I didn't know it, and then they have them do a bad Italian accent because that's a joke. There are numerous ways in which these direct-to-consumer DNA tests are sort of problematic, and we can break this. I've broken this down into 4 categories. This is, again, if you're not familiar, these are the it's Helix, Ancestry, 23andMe, the things that purport to be able to tell you where your ancestors were from based on your DNA, based on doing what they say is genomic sequencing, but is not really. I mean, I'm sure they do sequencing, but they're not. It's not actually looking at a map of the whole genome. We'll get into that. We'll get into the science. But we're gonna start with business first. I'm gonna try and onboard people who are maybe skeptical by saying, like, look, the business model is shady to begin with, and then we can move on to the other stuff, right? So these ancestry tests, 23andMe, Ancestry.com, Helix, they all have the same business model, generally, right? They, they produce a kit, right? It's a little like cheek swab thing. And you purchase the test kit, so there's money. And you, the patient that's the purchaser, or the person who wants to find out their DNA history, right? Like we're in Assassin's Creed or something. Put some cells in a tube, right? They spit, or it's a cheek swab. They put in the mail. They wait. The company does some sequencing, right? And then they email you some DNA results. And it tells you, oh, you're actually 0.3% Scandinavian and 22% Grecian and I don't know, some other stuff, right? But then they sell that information, right? So this is where most people think it stops, right? Oh, you purchased the thing, they did a service. This is not, right? They're selling these test kits for, I don't know, $80 a pop. This is not the business model that allows them to purchase these ads, all the ad buys they do at such a high volume. The place that they make a lot of their money is selling your genetic information to pharmaceutical companies. That's where they get money in as well, right? So they're actually making money on both ends, right? If your job is to make chairs, right, you have to buy the wood or do some work to get the wood, put some labor in to get the wood, and then you make a chair and then you sell it. Most business models don't actually get money in on both ends. And in case you're thinking that I've got some sort of tinfoil hat on here, right? That's like, oh, well, no, they're not actually doing that. Grow up. There would be rules. In July of 2018, right, here's one big example. GlaxoSmithKline, a very large pharmaceutical company, invested $300 million in 23andMe in exchange for a 4-year deal, during which they get access to all genetic data submitted to 23andMe. And again, in case you're still sitting there thinking, well, nah, tinfoil hat Tim is out here doing this. No, we can pull this right off GlaxoSmithKline's website. All right. They signed an agreement to leverage genetic insights into develop novel medicines. And this sounds nice, right? Like they're framing it as like, oh, we're going to be able to make better stuff, but we'll get into some of the implications thereof. The other service that these companies offer is actually to connect you with any relatives you may not be aware of, right? Finding new family sounds great, depending on your views on family, but maybe it's, I don't know. This is actually where their science is the best, right? This is the thing that the science can actually do. But what this means, right, what you may not realize is that in order for them to match you with people who are related to you, they must be storing your genetic information, right? They're saving that. They're not just they're not taking your information or your DNA, sequencing it, and then sending you the results, and that's the end of the day. They are storing that information. Now, I don't know if you remember how many how many companies have had data stolen in the past, I don't know, 5 years, 10 years, but it's a lot. It's a lot, and DNA is a super personal thing. And here's the thing, if you don't, like, DNA is in some ways incredibly anonymous, and in some ways just the least anonymous anything can be, right? Because DNA is right, it's the thing that determines most of the things about your biology, or a large percentage around most things about your biology. If someone just has some DNA, and it's not associated to anything, they can't tell that that's your DNA. But if they know that they have your DNA, they can tell a lot about you. And DNA is in many ways not anonymizable because it has information about you, but it's also very complicated. But de-anonymizing data is actually incredibly easy. There was a study that took Facebook posting and pedometer data and was, with I think like 92% accuracy, able to match the pedometer data with Facebook posting habits, with who posted, right? So able to accurately identify it. So if they're like, those are two pretty disparate things. All you need is, right, in some ways data is not the only anonymizable data. The only anonymous data is just there was a man, right? That could be anyone. But if you then start attaching that information to that, right, that is there is a man. He is 34. Okay, this is a subset of men. He, every night, his phone is in this same place, and then during the day, he drives to this other place where he works. Now, there is only one person in my house that sleeps where I sleep and works where I work. Right? You can see how this data can become unanonymizable pretty quickly. In addition to that, not all companies are really storing your information in the most encrypted format. So all they need is, right, once they can connect some information to your name, then they can, again, I sound like a tinfoil hat person here, but the fact of the matter is that, like, this is something that computers can do. They can match information to that, and all you need is one sort of loose link in that chain, and they can get people can get a lot of information about you very quickly. And once they have DNA information, that's a lot of stuff that you have the right to keep private about yourself, if you so choose. But there's more to this, right? Not only do they keep your information, they also keep the physical sample, right? You know that part of your body that you scraped off your cheek, and then you put it in a little vial and you stuck it in the mail? They keep that frozen. They have, right, we have big freezers, big sort of minus 80, minus 160 degrees Celsius freezers, stores cells really well. So you paid to send them a part of you, something that has your DNA in it, and they have kept that. If you want that to be destroyed, you need to contact the company and request that that happen, which for some companies can be pretty tricky. And then you just get to take their word for it that they've destroyed that DNA, or that they've destroyed those cells of yours. So at this point, hopefully I've onboarded some people to this idea that like maybe we should take another look at these companies. Certainly, at least the business models seem perhaps a bit sketchy. But now let's get into the science, right? This is where I really come in. I'm not a business person. I have no idea how business works. I have some vague ideas. But let's talk DNA. The process of testing, of sequencing DNA, right? The thing that they do is actually pretty simple. They collect cells, right? You do that yourself. You collect some cells. They lyse these cells. Remember, lyse is our fancy-ass science word that just means break open, break apart, to burst, right? So they break these cells open, then they take the DNA. They harvest and sequence the DNA. This is really easy. This is pretty easy to do. They've got machines that can do it real quick. Then they then identify single nucleotide polymorphisms, or SNPs, we'll call them, which are then analyzed. Right, so they say, okay, well, we're not going to look at the whole DNA because, I don't know, we've got like, I don't know, 2.5 trillion nucleotides in your body. 2.5 billion nucleotides in every single one of your cells. Just double check. It is 2.5 to 3 billion nucleotides, or base pairs in a single cell. So that's a lot. So they only look at some of them, right? They look at these single nucleotide polymorphisms as just, these are the places in which two sequences of DNA are likely to differ. They then compare these SNPs to various reference populations, right? They've collected some data from people who live in Sweden, and people who live in Wales, and people who live in China, and people, or different parts of China, people who live in Japan and Australia, and all these different places. And they compare and say, all right, well, how similar are you to these people, right? This is just what sort of finding a close relative is like. But these two steps here is actually when things get kind of dodgy, right? The SNPs that they choose and the way in which they analyze them, as well as the reference populations, this is where their science gets bad. And their science gets really bad. We're going to start with being sticklers for tradition. We'll start with the first one. A SNP is a difference of any single nucleotide when you compare two DNA sequences. All right, so two people, right? If you compare a human and a banana, it's always a banana. But if you compare a human and a banana versus a human and another human, there will be more SNPs, more points of difference between the banana and a human. But scientists, right? If you want to say what is the potential difference between any two humans, there are 100 million points of difference that have been identified. Scientists have identified over 100 million potential SNPs, right? Out of every single piece of human DNA that they've analyzed, they've said, here are the places in which there is any potential difference. And we have roughly 3 billion base pairs in our genome. That's 3 billion potential SNPs. So 100 million out of 3 billion, that's a fair percentage for how different people could be. So there's over 100 million places that any one person can differ from another. As far as we know. As far as we know, there are over 100 million. So how many SNPs would you say, right? So what percentage of 100 million would you be comfortable in saying, like, oh, okay, these two people are different, right? If you might say 2%, you might say 50. You know, maybe we should check half of them so we can tell how different, you know, these whole different populations of people are. Well, they check less than 1% of these 100 million potential differences. 0.64 to 0.72%, depending on which test you look at. MyHeritage tests the most at 720,000. Family Tree DNA, another 720,000. Ancestry goes down to 650,000. 23andMe is 638, 640,000. This sounds like a lot of places to check, but it is a small fraction of the potential number of places, right? Of all the potential differences. So they picked these places and they said, we're going to look at these ones, right? These 720,816 SNPs. They're going to look at those. So the algorithm analyzes these, right? They have algorithms. They say, okay, well, tell us how different these are. And it's not like one SNP is associated with Irish folks, right? And another SNP is associated with Scottish folks. It's going to be a pattern of many other places. And these are all likely going to be non-coding sections because they want DNA that is not subject to selective pressures. So likely they're not super, as far as I found, they're not super apparent about exactly which SNPs they test. But so it's kind of like, if you've ever done one of those like Kafka things where there's like some weird letters sort of written like R, right? So it's like R, that's not even, what are you doing, Tim? That's not an R. All right, so they, and it says like, oh, write what letters these are, and it's like a T, right, and an R. I'll prove I can draw an R. This always happens, right, and like a 3, right, and you have to type TR3. That's because computers are real shit at looking at an image and saying, I know what this is. This is a duck, or this is a whatever, right? So they're actually very bad at reading these types of things. And this is analogous. It's not exactly the same, but this is analogous to how the algorithm looks at a very small section of the overall potential differences. So what the computer will do is when it looks at like, let's say it wants to identify Starry Night, right? It might look at a couple of these spots and be like, okay, well, this is a pattern of Starry Night, right? We can make a sort of fingerprint or a genetic, or not genetic, but like a profile of Starry Night. We can say, okay, this is Starry Night. If it's got these colors, right, these pixels at these positions, this is Starry Night. Well, I don't know, it's a fair way to look at it, I suppose. But it also leaves open a lot of potential for whatever the hell is going on in here, right? There's all this other stuff that's not in use, right? To the computer, this image and this image are both Starry Night. So this image, and this image are all Starry Night. By the way, I commissioned this picture. It's a very weird experience to ask an artist who draws well to draw you a bad picture, but sometimes life is weird. So you can see here that by not looking at a complete picture, right, and actually by looking at a very small percentage of it, we can see where the potential downfalls of this sort of methodology are. So this is the problems within their analysis of the DNA sequence itself. We're going to move on now. We're going to look at this dog for another moment. It's a good dog. And we are going to then move on to the reference populations. This is where things get real bad. This is the second place that these science tests are kind of doing science poorly, right? The first way was the way that they analyzed the genome, and like if you want to say that two things are similar, I don't know, ideally like you to look at least 1% of them, probably more, maybe look at 20% of something. So the way that this works is they say, oh, well, we can tell you where your DNA, right, where your ancestors lived based on some DNA that we took. But here's the thing, they didn't go back in time, right? They didn't back to the future this and go and get some DNA from a couple hundred years ago. What they did was they went to places and they said, hey, have you lived here a while? People said, yeah, sure, yes, I believe that my family's lived here for generations. They say, and they say, okay, cool, can we have some DNA? And they say, yeah, sure, maybe they compensate them, I have no idea. But that's sort of incongruous to what the test is saying that it can do. It can say, oh, well, maybe you have secret other ancestors coming into your family tree. And like, yeah, that's also true of your reference population. Even if you believe that your family's lived there for a long time, things like sexual assault or any number of terrible things are not things that like come up at family gatherings. People tend to keep those secret, right? Infidelity, right? This is the types of things that these direct-to-consumer DNA ancestry tests claim they can provide, but they have no way of knowing if their reference populations are accurate. Right? It assumes several things about these reference populations, including that they're sort of genetically homogeneous or that they tested a large number of people. We'll get to that. But that people from a given place are going to be genetically similar, and that is broadly accurate, right? We know that lacking sort of transportation by plane and sort of pre 18th century, there was not the degree of sort of mobility that we have now, and you tended to be similar to sort of genetically similar to the people that you live near. This isn't surprising, right? This is not an argument for the existence of race. It's just saying that if people don't move very much, you tend to be more similar to the people closer to you as opposed to people further away from you. See the previous lecture. See lecture 2A in this series for more information on that. So this is suspect. All right, this is sort of iffy for a couple of reasons. For example, many DNA heritage tests sort of label Native American as one single category, which represents North, Central, and South America. Which that's a big area to label as one thing, right? And how many people do you think would be a good reference population? I would say probably 146. Or sorry, probably more than not 146. I'd probably say a couple thousand, right, to represent North, Central, and South America. I don't know, 10,000 seems like a better number than 146, particularly given that there are currently 562 federally recognized indigenous tribes, indigenous groups within the United States alone. That is ignoring Canada, Mexico, Central and South America. I mean, and if you don't believe me, we can just pull this right off their own website. Here we have Native American, North, Central, and South, 146. They also have Andean, which seems like a weird single subcategory to have, but I don't know. At least it's not as bad as I don't know, Thai people or Vietnamese people. East Africa, North Africa, 41. This is a real sort of this is not a representative population in the slightest. This is not even a little bit of representative population. Even one of the largest groups, right, England, Wales, and Northern Europe, is only 1,500. You can go to this website yourself and find, and they list all this themselves. So the population that they are referencing you against is a very small sample size. If you remember anything from sort of science classes, you know that you want to have a large sample size, or the larger your sample size, the more believable your data is. If your sample size is real bad, right? If your sample size is real small, you cannot be sure of your results. So heads up for the next slide here. These direct-to-consumer DNA tests are sort of marketed to people as a way to find out where they really come from, right? Yeah, you think you've lived in Germany for, you think your family's been in Germany for a couple hundred years, but where are you really from? Or they may be marketing this to, right? And this is, again, from their website. This is very often marketed at places in the United States, for example, where we've had a large degree of migration, or a large number of people entering the country over the past couple hundred years, or entering the area over the past couple hundred years. Now, heads up for this next slide, right? they have no way, again, they have no way of determining if these reference populations have unknown or undisclosed differences in sort of parentage or genealogy that they may not know, right? There are numerous reasons people keep those secrets. Various forms of sort of assault, what's the word? Infidelity. In addition, they also have advertising that is targeted directly at African Americans, whose ancestry is often unknown because their ancestors were literally stolen from their homes without a lot of detail about who was being recorded, right? These people were considered property, and they were just extracted from one place, brought somewhere else, and there was not record keeping going on for this, right? So the idea of and this is as I understand it, again, I'm a white man, but so I don't want to speak for marginalized groups, but my understanding is that this is, understandably, a source of great pain within the African American community, right? That this is a unaddressed injustice, and sort of not knowing sort of where your family, right, where, I don't want to say where you're from, but like not knowing much about your family history is a lot of us have very deep ties to our family. So the idea that there are people out there who don't have access to that information because it literally doesn't exist is very is heartbreaking. So it makes great business sense for them to target these tests towards African Americans. So, and finally, even if we use their own metrics, right? Even if, and I do not recommend believing their metrics, but even if we believe their own metrics, right? There is more, there's people within racial groups are more different or not genetically similar, right? Based on their own information, right? Based on their own testing. Your descendants of enslaved people in the United States have more, quote, European markers than many white Americans. This is garbage science. This is garbage science that is being used to extract DNA from millions of people and sell it to companies who want to use that information to make money themselves. Part 3, the concept. Or, how DNA heritage tests perpetuate explicitly racist ideas. So these tests are based on, right, one of the underlying assumptions of these tests, right? We always want to look at like what the assumptions behind the sciences or behind these, you want to look at what the assumptions underpinning things are. So these tests are based on and sort of reinforce the idea that there's only one type of person can come from one place, right? When we say Swedish, we know what Swedish looks like, right? When we say German, we know what a German person looks like. When we say American, a lot of people have a very solid idea about what an American looks like. The idea that, right, we know this is not true, right? That there were dark-skinned people in Rome as far back as 500 BCE. We know this because they made busts of these people. They sort of immortalized people in statue form. We know that dark-skinned people existed in Rome. So the idea that we know what an Italian person looks like, because obviously Italian people are white because they're from Europe, right? They're European. So we have this concept in our head of Europeans or Italians as being white. So the idea that only one type of person belongs in one place. This is also exactly the kind of people or the kind of thinking that people who are looking to establish some sort of white ethno-state are very interested in perpetuating. The ideas underpinning, right, the assumptions underpinning DNA ancestry tests are fundamentally racist. at the very least, racialist. Right? But our concept of ancient Rome and medieval times is largely shaped by popular culture. If you were to ask, what does a Roman look like? Right? I want you all to picture in your head right now, what does a Roman look like? I'll tell you what most people picture. They picture, I don't know, Russell Crowe, whoever these people are, right? It's a whole lot of white people here. Here's Cleopatra. Right? They're not Roman, but also very white. We take, and you could make the argument, oh, well, that's just because of the hiring practice at the time. That's, sure, yes, but the things that we believe about people and places and history are largely shaped by popular culture. Right? We see things like, oh, well, they must have done it must be based on something. So, and we take this in without even realizing it, and we internalize it. Popular culture gets all sorts of stuff wrong, right? Shakespeare had a clock, Julius Caesar, cool, right? One of my favorite examples here is that potatoes are fucking everywhere in medieval fiction, right? Go watch Lord of the Rings, which is just a just allegory, stand-in for medieval Europe, medieval England. That was actually what it was, the idea, right? J.R. Tolkien sort of set out to create a mythology of the British Isles, because there's actually not a lot there, right? Even something like King Arthur, Sword in the Stone, is based on a French story, right? In his opinion, there wasn't enough sort of mythology about the area, so he set out to make some of that. But potatoes originated in Peru, I believe, and did not arrive in Europe until the 1600s, and were not widespread until, I believe, like the 1700s. But you go watch anything set in sort of medieval era, and you will find potatoes all over the goddamn place. Another example, right? I asked you to picture what a Roman person looks like. I would like you to picture now what a cowboy looks like. What's he look like in your head, right? He's probably maybe he's got some spurs, he's got a big hat, maybe he's got a bandana, but he's probably white. Whereas the historical record tells us that, right, that about 25%, a quarter of all cowboys were black. So, but we have this conception of what history looked like because of the way in which popular culture, or the way in which media has portrayed it. So if you ask most biologists about race, you'll get some variation of sort of race is not a meaningful genetic category. Again, we talked about this in depth in the last one, but I want to do a brief go on it here. Right, it misses several points, not the least of which is that sort of the goal of biological anthropologists, if you ask them what their goal is that, oh, well, you know, we want to find out how people are the same. We're not trying to support sort of the idea that races are a real thing. But my point, and I believe this was made by, the first place I encountered this was Jenny Reardon and Kim Tallbear, that the research methods of these researchers are antithetical to their actual stated goals. That you do not determine, right, we do not enter some sort of post-racial society by doing research into the ways in which the races are different. The ways in which races of people are different. There are only, I think, like 7 genes that are specific to any one race, I believe, top of my head. And that's because race isn't a biological category, right? It is not a genetic category. Race is a collection of, we define race based on a collection of superficial physical features, which do have a genetic origin, but that is not a basis for a genetic category. We don't rank people in society based on whether or not they've got a butt chin. Part 4, their use. How are these DNA tests used? Actually, I want to talk briefly about there was a great sort of news article I read a couple years back now about, they had 2 identical twins send their information into different different DNA testing companies, with the idea being that, well, that if they're identical twins, they should have pretty identical results, and they did not. And different companies gave them different information. They also had different sort of makeups from each other, which is a pretty damning indictment of how bad the science is that underpins this. So how are DNA tests used? All right, let's return to part 4 here. In addition to selling your genetic data to pharmaceutical companies, they've also made this database available to the FBI. Not only is it being used by the FBI, you can opt out. However, a recent court ruling has said that not only are these companies morally obliged to turn over the information, but even if you opt out, your genetic information should still be turned over. That is just an incredibly worrying invasion of privacy. And here we go again with the tinfoil hat. But like the genius of a lot of these sort of invasions of privacy is that they're so ludicrous that when I say this, people are like, that can't be true. What are you talking about, Tim? That's ridiculous. And if the other response could be, well, then don't do any crimes. I have 2 responses to this. 3. First is, what if they redefine what a crime is? But next, you do not have to be the one committing a crime. Remember how you can find close relatives based on DNA? And this all stems from the Golden State Killer, which the first place this happened, where they sort of used this information, which had actually been posted to publicly available things so that people could try and compare information across different services. And I'm not sort of against the locating and sort of rehabilitating of murderers, not getting into an argument of a discussion of sort of ethics of imprisonment, but the finding close relatives is actually the only part of the science that is accurate, and they only need to have like 5 to 10% of the entire population in order to find any one person, based on things like third cousin, right? Based on you're only related to so many third cousins, right? And if you can say, okay, well, this person is sort of third cousins to this person, this person. Sort of like if I said, okay, well, your X distance from DC, Y distance from Richmond, and Z distance from Roanoke, right? There's not many places that are going to be within that sort of triangulation. So you can be accused of a crime just because a relative committed one. Potentially even a relative you do not know about. We've seen this with facial recognition software. There was this case of a man who was, right, he's a man sitting in his house having a reasonable day. Knock on the door. He goes and opens the door. He's tackled to the ground by law enforcement, by some cops, and he gets his ribs broken, right? Because his face was similar to someone that had robbed a bank. I believe it was a bank. And this man it was not him. He was a very different person, just looked similar to him. And he got assaulted and ribs broken, and that's solely based on your face looks similar enough. And here's the kicker. That shit happened to him again. It happened twice. This is based off the big data of facial recognition. Right? And I would also ask, perhaps you're more comfortable with the idea of with sort of having genetic information out there because you're not a member of a group, perhaps a racial group, that is presupposed to have committed crimes. And if you think I'm getting a bit too sort of lefty on this, this next slide will address that. And again, there are content warning for racism and suicide on the next slide. I would like to tell you about a young man named Khalif Browder. He was 16 years old when he was detained at Rikers Island. He spent 3 years in prison without being convicted of a crime. I say without being convicted of a crime. He spent 3 years in prison because he was accused of a crime. He never saw the inside of a courtroom. Now, I don't know about you, but if I was in prison for something I know I did not do, I would not be particularly compliant. I might be grumpy about it, to put it mildly. So he made a bit of a fuss. And for that, he was treated, or he was dealt with the way that the prison system deals with this, which was punishment. So subsequently, he spent 2 of those 3 years in solitary confinement, which is defined as torture. Solitary confinement is torture. He was eventually released after 3 years, when the case against him was just thrown out by a judge, basically saying, "Why are you here? This case has no merit. You should not be in prison. Please go. You may go." And unfortunately, less than 2 years later, he took his own life. So at the age of 21, this young man took his own life. And this was all because he was, again, never saw a court, was never convicted of anything. It was all because he was accused of stealing a backpack. Somebody said, I saw that black man, steal a backpack. A police officer said, okay. They couldn't find the backpack. No other information other than an accusation. And he was arrested. 3 years in prison, 2 of those solitary confinement. And he is dead now. And that was without any evidence. What if they have some faulty genetic evidence, right? If this can happen to someone without evidence, with just an accusation, it is very worrying to think about what could happen if there was sort of genetics behind it and all the sort of the weight and objectivity that people attribute to science. So as I stated before, searching for a biological origin of race is something that absolutely benefits people who are espousing racist ideologies. The idea that there is some other person that is coming and they are dangerous. There's somebody out there who is a threat to you. And we're going to take a moment here. I just want to talk about, we're going to talk about race and whiteness. But the thing I don't want to happen is I don't want someone to turn off and be like, oh, well, I'm not, I'm white. Why is he accusing me? I'm not accusing anyone of anything, right? I'm also white. And this is not sort of being done out of guilt or something ludicrous like that. Let's talk about what whiteness is. When we're talking about whiteness, right, it can be difficult because our gut reaction is like, well, that means anyone with white skin. And I have previously had reactions like that. This used to be where I was at until it was explained to me. So hopefully I can sort of do the explaining for someone else. Whiteness is, yes, it is concerned with skin color to some extent, but it is not solely that, right? When English is a muddy language, when we say white, there's a lot of other things that go on there, and we're also specifically talking about whiteness. And things are always more complicated the more you dig into them, the more you learn, right? And it turns out if we look at the way that whiteness, right, and who is white, who gets to be considered white, and who gets to be considered really white, like who's white but for real, right? Wink, nudge. Yeah, they're not, right? Some people aren't. They may have a light colored skin, but they're not really white. Whiteness has been a fairly elastic concept over the past couple centuries, right? Race was really only introduced as an idea in the late 16th century. And the whiteness has been sort of expanded and contracted as needed to fit certain situations, largely expanded. All right, that is to say, who society considers white has changed. Who gets to be at the top, right? Because whiteness always frames itself as the most ideal. those who were truly white, right, in much of like the 19th century were actually Saxons, right? This is broadly speaking people from Northwest Europe, which is then expanded to include other sort of Nordic race, Nordic, no, some races, Nordic people, right? So sort of Scandinavian, Italian, Portuguese, Irish, Slavic people from Poland, Russian people, Ukrainian, anywhere from sort of Eastern Europe, which is still sort of in many ways sort of a loaded term. You're like, oh yeah, but it's Eastern Europe. They were seen as other, even though they had fair colored, right? Even though they had light colored skin, like I do, they were not seen as white for real. We can see this in science, right? Historical science, right? How many jokes do you know about how unintelligent Polish people are? How many times have you heard those jokes, right? How many, Irish need not apply. Italian, American, anti-Italianism within the United States. Now, I have a quote here from Robert Forster, who I know nothing else about, disclosure, but it has to do with how Italian people were viewed in the United States in the 20s. In a country where the distinction between white man and black is intended as a distinction of value, it is of no compliment to the Italian to deny him his whiteness, but that actually happens with considerable frequency. By the words of the time, Italian people were not considered to be truly white. However, this definition has since been expanded, right? And the thing is that whiteness is largely a system of power. It's a system of exclusion, right? And it says we are the real group. We are the real white people. And we get to say who is not. We get to deny other people entry into this club. It's a system of power, right? And power does not make exceptions of people randomly. This anti-Italian, anti-Irish, anti-Polish, Slavic, Polish or Slavic prejudice existed in the United States because there was immigration, right? So post the Irish famine, there was immigration into the United States. There were other historical issues that, material conditions that ended up causing people to emigrate to the United States. But these definitions, right? Who gets to be white sort of is expanded as we've had subsequent amounts of waves of immigration. People are not seen as other when there are other newer people to see, right? This who gets expanded is not random. And here's the thing, right? If having white skin, if having pale, fair skin was the only thing that was necessary for inclusion into the club of whiteness, why does a term like white trash exist? White trash is definitionally a term that says, yeah, they may have that kind of skin, but they're not really one of us, right? They're not one of the good people. See what I'm getting at? And recently I've actually noticed a lot of emphasis and coming from ethno-national or white nationalist segments of population, this idea of European American as a synonym for white, right? Like there's the old phrasing of like, well, they have a thing, they get to have their own term, African American. Why don't we get something? So that people have decided on European American as some sort of synonym for white. I've got news for them. I don't know if they've been to Europe, but there's a lot of different colored skin in Europe, and color of skin is not important, right? Here is Cristiano Ronaldo. Here's the Italian basketball team from the 2016 Olympics. Let's go back to 500 BC, and there were dark-skinned people in Rome. None of these people's skin, maybe this guy, but none of these, no one else's skin looks like the skin that I have. Right? If light color skin was the only metric needed to be inclusion in sort of the white club, apparently didn't finish the sentence, right? again, we wouldn't have terms like white trash. Right? So historically, whiteness, if we look at the way the term has been used, the way whiteness has been used throughout history, it has been used as a tool of exclusion. We get to say, right? They say we get to say who is admitted into this club, who are the real people, right? This goes back to the ideas of racial hierarchies, right, that we got from Carl Linnaeus or Immanuel Kant or any of the other people who came after them. It was very fashionable for sort of scholarly gentlemen, right, gentlemen scholars, to sort of come up with their own hierarchies. I don't know, it was boring back then, I guess. They need something to do. So the ways in which these tests are used, right, these DNA heritage tests, or ancestry tests, are just a new method in this older tradition of oppression and exclusion, right? Whiteness, or white people, have a long history. Again, we're not talking about all people with fair skin, right, with light skin. We're talking about the people involved, right? I guess it could be more accurate to say people with power, but I don't get to make up the terms that people use. So white people of power have a long history of excluding people by telling them they're not white, or they're not white enough. This method of doing the method of doing this is to tell people what they are. You're not white. You are something else. You might look white. There is a term called white passing that exists within marginalized groups. This is it's a whole thing. If you want more information on this type of thing, I would recommend looking up information on what is called the one-drop rule. Sort of the idea that as long as you are even slightly, not completely white, then you're something else, right? You've been tainted, sort of the very pejorative way that it's that the term is used. This also frames whiteness as default, as the default. If you remember back to our lecture on gender, when we talked, Simone de Beauvoir talked about how femininity is often portrayed as its through its contrast with masculinity. Other races have definitions, but the whiteness there's no real definition. It is the absence of other races, right? Whiteness is the default, of which everything else is defined by how it deviates from whiteness. This is something we still do to indigenous people today. In order to be recognized by the federal government as Native American, you must prove that you are at least 1/4 Native American. You can do this a couple ways. But the term for this is blood quantum. We trace back to the Indian blood law of the early 1700s. So sort of reference the concept of mixed blood, or not having pure bloods, or not having pure blood. A lot of this, if you, enjoy Harry Potter, you may have heard some of this may sort of be familiar as what the allegories were there. I hope I don't have to explain how disgusting this idea is, right? The idea of mixed blood. But this tool here, right, this blood quantum, it turns out indigenous groups, tribes they are their own sovereign nations. We don't define who is American, or who is German, or who is any other ethnicity, any other nationality based on who your parents were, exclusively, right? What it means to indigenous societies to be a member of that society is more complicated than just who your ancestors were. But we have taken the concept and twisted it and used this concept of blood quantum in order to say who is not indigenous enough. All right, so it's not how being indigenous works. These are sovereign nations. They do not care about blood quantum. when determining who is or is not a member. It is only a tool used by the federal government, the American government, in order to determine who they recognize as indigenous enough. Right? It only matters to the settler government of the United States. Right? We say this is a tool of who is not indigenous. And a real gross reversal of this history is actually made possible by these DNA tests. Not only has this power structure enabled other people to say, like, no, we don't think, you're not actually indigenous enough. There's now a gross reversal in which people who are not indigenous are using this as a mechanism to try and claim that they are actually indigenous. Right? These kids have emboldened largely white people to claim that to claim indigeneity more boldly than ever before. We had a whole ass presidential candidate who did it. So within this same system, we are both denying the indigeneity of indigenous people while allowing white people to claim it for themselves. So, conclusion, is race biological? No. No. But components of what we think about it as race are caused by genetics, right? Skin pigmentation, eye shape, etc. But that's very different from saying that race is a biological category. And we've applied these lessons to DNA ancestry tests. Thank you very much for joining me on this journey of 3/4 actually presentations. I hope that it was illuminating and sort of gave answer to the question of why biology matters, right? Why was it important that people have an understanding of what DNA is and how heredity works? Fundamentally, it's because it's been misused a lot, and this lack of understanding has allowed people to misuse this for their own ends. And it's, as someone who has the knowledge about this and understands how it's being misused, I feel like it's very important for me to try and explain that biology can be a lens through which, or a lens for justice. So thank you very much. I hope everyone is staying safe. Have a great day.